Actively engaging. I will say this, very good mathematical conversations. One of the things I want to emphasize and remind you is if I'm trying to work with these forms and identify those key features, what do I need to think about first? Guys, what's the first thing I need?
Concavity.
What do I need?
Concavity.
Before I can figure out concavity, I mean, yeah, concavity is important, but before I can figure that out, there's something else that I need. Presentation remote. Anyone see that little black remote? Why y'all guys steal my stuff? I'm kidding. Obviously, you don't steal my stuff. Oh, I'll get going with that. I'll find it later. So, guys, if I'm looking, okay, first off, agenda. We're finishing up this textbook lesson. We're actually going to start writing equations for quadratic functions today, dyu for the last 20 minutes. So, connecting forms of quadratics with the features. And that's what this is all about, identifying each form of a quadratic equation. Hey, by the way, what is the first thing you need to do if you're going to figure out if an equation in a graph can match?
Identify the form.
You got to know the form, right? Because if I have vertex form, am I looking for roots? No, right? If I have vertex form, I'm looking for the vertex. So keep that in mind. We do want we want to determine the concavity no matter the form, but keep that in mind. So you've got to identify the form. If I were you, the first thing I would do on every assessment, every time I'm dealing with a quadratic, I'm going to write out my three forms, which I only wrote out two of them. Right? But if I look at those three forms, remember this top one, what do we call this top one again? That's factored form. And we can clearly see R1 and R2, meaning I'm looking for the roots, right? The x-intercepts tell me that. Whereas the second one, that H and K, tells me about the vertex. Okay, so keep that in mind. Those different forms tell me what features to be thinking about. And so, we are here now. And so in A, I think the only ones that were identified were F1, F2, and F8. Does that sound right for all those? Okay. So here's a couple of details I want to ask about. What was the issue with F3 right here?
Please excuse this interruption. Can we have all juniors' last names beginning with G through L?
By the way, I forgot to look, but 2, 6, and 8, forgot to put your phones back up. Okay. So why does F3 not work? It's concave up. So that positive 2 for my A tells me concave up. Would these features have worked? One, what feature are we talking about there? The roots or the x-intercepts. What would my x-intercepts here be?
-1, -4.
Okay. Anybody want to push back on that? That the x-intercepts are -1 and -4? I want to push back a little bit. I want you to think about the language there. Be careful. What are the x-intercepts? Super close. Closer. -1, 0 and -4, 0. Remember, when we're talking about x-intercepts, they're on the x-axis, right? What's the y value on the x-axis all the way through? The y value is, notice how it's between -1 and 1 for y. And so the x is -1, the y is 0. The x is -4, the y is 0. So it's okay, that's just part of the learning process. Remember, it's literally an x-intercept, so the x value is -1, the x value is -4, and the y value is 0. And remember, you can see it. Two things, right? We looked at that factored form as being A times x minus R1 times x minus R2. Because there's that minus in there, what do I always need? I need the opposite, right? The opposite sign. But also, when I look at this equation, if I substitute a positive 1 in, what's 1 plus 1? 2. Does that give me the 0 that I so desire? No, I need a -1. -1 plus 1 is 0. So keep that in mind. We're trying to create those zeros in there. Other than that, I think that's all I got. Were there any of these that you needed to ask a question about? That was the biggest conversation piece that I saw. I know y'all talked about it, we came to a consensus, but maybe there's one you're like, I really thought this might work. Remember, if you don't ask a question, I can't answer it. Going once, going twice. Okay? B here, right? So when I look at B, which ones did y'all identify? F1 and 3? Those were it? I think those are the only ones I saw around the room, so we're all in agreement. Again, remember thinking about those forms, because those different forms tell us different details. So why does F3 work? Because like, goodness gracious, that's wild. Can you actually hit the lights for me? And Jaden, can you make sure the camera can see this piece real quick?
Yes, sir.
Why does F3 work? Okay, so what's concave up? Be clear with your language. The what? The parabola is concave up. Remember, you can write your standard form below, by the way. Because if you were to tell me, hey, A equals 8, so concave up. Notice like I'm very clearly giving evidence for that, right? Just thinking about those details. Please note, A is not the concavity. A is just a number, but it tells me about the concavity. All right, so why else does F3 work? The y-intercept is what? What is my y-intercept? Super close. Well, which one is it? Is it 0 comma or comma 0? So remember, it's a y-intercept, so the y value is 240, the x is 0. Remember, we saw that clearly because if I substitute 0 in, what does this become? 0. If I substitute 0 in, what does this become? 0. So I'm left with 0 minus 0 plus 240. The whole idea of a y-intercept is that the x is equal to 0. So keep that detail in mind. Now, I'm good with all that. Let me ask you this. Let's say I change this one detail about this. Would this quadratic work? Notice instead of a minus 88x, I made it a positive 88x. Would that work? Any ideas? No ideas?
No.
I mean, does it still have the same concavity? Yes. Does it still have the same y-intercept? Yes. Are there any other features that are not immediately visible, though, that we might want to check in this case? We got y-intercepts, concavity. There's a feature that you can find, but it's not immediately visible. Elizabeth, you were looking at it for that factored form earlier. Could I try to find the vertex here? So remember, the vertex is not something I'm testing you on to hit the target, but to get to the what do I call it, advanced, no, exceeds portion of the proficiency scale, and is going to impact your understanding for the next unit. How do I calculate h, the x value of the vertex, from standard form? Negative b divided by 2a. So what is the opposite of b in this case? Negative 88. Divided by?
2 times 8.
2 times 8. I'm actually going to make our lives a little easier. I'm going to make this a 4. Still concave up. So what's 2 times a in this case? 2 times 4, which is 8. So I want you to think about it. Could this parabola, could F3 now go with this parabola here? If h is negative 11, starting from the origin, which direction is that going to go? To the left, isn't it? So could that work in this case? No. I just want you all to think about that and be aware of that and consider that the vertex would not work if I went to find that vertex. So if you're trying to go for that exceeds, if you know, hey, I got the target on lock, and you're trying to go for that exceeds, and I highly recommend that because it's going to help you next unit, hey, that h value does not work. And we talked about this earlier, Elizabeth. What are you going to do if you want to find the k in this case? What's a more mathematical term for that? Substitute it in, right? Remember, if I substitute h in, what do I get out? Okay. Input and output, the x and the y. So if I were to substitute that negative 11 in, and I don't know exactly what I would get, but that's it. That's how I would find my vertex. Does anybody have a calculator on hand that they could type that in? Thanks, Crystal. Don't quote me on that. Which way? You got this. While Crystal's figuring that out. Is that right? Yeah. There's some patterns that I've discovered that I'll show you all soon about how I got there. Because I don't know 88 times 11 off the top of my head. But I knew that this was going to end up being double that 484. Again, a pattern I'll show you all later. It's kind of cool. All right, so moving on to C. Last little bit here. With C, I know we all came to an agreement, same answers. There was something I wanted to look at with C, though. I don't remember exactly. Oh, two things I wanted to look at with C. So I want to bring attention over to here. Jane, can you turn the camera this way? So something Elizabeth was working on. So, and her whole group, when I came over, she's the one who asked. Notice with F1 of X, what did Elizabeth and her group start looking at, finding? They started to find the H, right? They started to look for that vertex there. And so once again, I want to emphasize, and be careful, because originally when I came over, they told me that H was 3 because they had a positive 1 here and a positive 5. First off, if that's plus and that's minus, could they both be positive? No. No, right? What does that R1 have to be? R1 is negative. Well, negative 1, right? Well, so be careful. X-intercept be negative 1 comma 0, but what's just R1? R1 on its own is just negative 1. The x-intercept is negative 1 comma 0. So keep in mind that difference between a root, right, and an x-intercept. The root is the x value, the x-intercept. But from there, negative 1 plus 5 gives me 4. 4 divided by 2 is equal to 2. And so what did we do to find k? Substitute in. Guys, if you know what h is, all you have to do to find k is substitute it in. Once you find h, all you have to do to find k is substitute it in. That even works with vertex form. We don't have to do that with vertex form. But notice, if you substitute h here, what is h minus h? What's h minus h? 0. What's 0 squared? 0. What's a, whatever a is, times 0? And then 0 plus k is? So if I substitute h in, what am I getting out?
K.
That's why that works, right? To get k, you substitute your h in, you get k out. But the last thing I want to point out is this. Elizabeth, did you even have to find the vertex for this one? Why not? Yeah, if you look at that graph, were there any x-intercepts for that graph?
No.
So could we have had a factored form that shows us roots and x-intercepts? Could I have had a factored form if there are no x-intercepts on the graph? Guys, what do these tell me? Those are roots or x-intercepts, right? Are there x-intercepts here?
Yes. Maybe.
Does it,
I don't know.
let me ask you this. What is an x-intercept? It's where the graph intersects the x.
Wait, x value?
Well, so an x-intercept is when the graph intersects the x axis, right?
Okay.
That's the definition of an x-intercept, where it intersects the x-axis. Does this intersect the x-axis?
No.
No. So can we have a factored form?
No.
Not yet. We're going to study something called imaginary roots next unit. And I'm going to go ahead and tell you this. I want you to hold on to this idea. When it comes to polynomials, whatever the degree is, that's how many roots you're going to have. So if these are all quadratic, second degree, how many roots does it have to have? 2. It has to have 2 roots. But I can't see them yet. That's it. I just cannot see them yet. Okay? We good with that idea?
Mm-hmm.
Okay. So we cannot see those roots yet. We will find out how to identify those later. So number 2, this is what I want us to move into before we start writing our own equation. So number 2, consider the 2 functions shown from question 1. Identify the form of the function given, and then write the function in the other 2 forms if possible. If it is not possible, explain why. Okay? So, I want y'all to go ahead, I want you to take 5 minutes or so to work on 2A, and then we're going to talk about what I'm seeing and what I need to add on to. So, this is something that you know how to do for both of them. One of them we've already talked about this year. The second we haven't talked about this year, but I know you've done it in the past. So I want to see if you remember how to do this. So no more than 5 minutes. We'll come back together and talk about it then. Sound good? So 2A, if you finish 2A, move on to 2B.
Mr. Kennedy.
Yeah.
I'm gonna stop recording.
Yeah, you can stop recording. If I can grab your attention on looking at this, I want to talk about a couple of details. First off, which form did we have in A? You got it recording? Okay. Which form did we have in A here?
Factored.
Factored form. And so what are the other forms we want? We want vertex and we wanted standard. Okay, let's stop and let's think about vertex form. Guys, if you want vertex form, what do you need? You need the vertex, right? We need H and we need... Okay. So when I look here, how did y'all get a 1 and a positive 4?
I did.
Wait on that.
It's 2 X's.
So you just took these values from here? Yeah?
No. Well, they did, but no.
But what form is that?
That's factored.
That's factored form. I will point this out. One thing I want you to start to do, and I should have been having you do this in the past, but these aren't just like random things, right? This is telling me about the shape of the graph in detail. So like, what does that factored form tell me about the graph?
That's quadratic.
Okay, what else do I know about that parabola though?
It's concave down.
Concave down, I need some more.
It both the X intercepts.
Okay, what x-intercepts do I have? There we go, let's start talking about that.
What's that?
Four.
-1 and -4.
What's
Which one says it?
what's
I
the
think it
first
says
one?
positive
Is that
1 and positive 4.
Well, that's what it said, but got the inverse.
Yeah, I didn't know there was a 1 in
Is
there.
it positive or negative? One.
It's -1.
Why is it negative?
Inverse.
It's minus R1.
So remember how it's x minus r1, so I need the opposite? On top of the fact, if I substitute a 1 in here, don't forget this, what's 1 plus 1? 2, but what did I need this to become? 0, so I need a -1 and a -4. So, there's -1, and there's -4, and the parabola is concave
Down.
down. So concave down like this. That is a decent sketch of this parabola. So I want you to think about this again. What would this vertex be here? Positive 1 and positive 4? Does that match this vertex?
No, that
No.
does not. Well,
They should have a -1.
I mean, -1, positive 4 be here, right?
They
Ish?
should have a -3.
So we need to talk about this a little bit more. I need y'all to remember. And so I was talking about this with the group of eights, with Crystalline's group, and she was talking about H equals -b divided by 2a. But when I have factored form, what do I not have?
A B.
I don't have a b, right? So I'm not, I will say I can get there, and I'll show you all that in a second. But -b divided by 2a, can't use that. But can I find h from factored form? Where is that h in respect to my roots? Where's my h in respect to my roots?
In the middle.
It's in the middle, isn't it?
Yeah.
Remember how we looked in blue over there earlier, and what did we do to those roots to find h? There's an A word. We averaged them, didn't we? Don't forget the difference. Like if I have roots, I know my vertex my axis of symmetry is in the middle of those two things. By the way, notice if I sketch it pretty well, I actually have that h pretty well laid out. But what am I going to do to my two roots? I'm going to average them. Good job. And so I'm writing it out formally like this, but I would just do -1 plus -4 divided by 2. And so what do I actually get from that? Be careful with our work, right? H is actually -5 divided by 2. And I can see that, because if I take -5 and I divide it by 2, I get -2.5, -1, -2, -2.5. Right there in the middle. And so from there, what was I going to say? Oh, how am I going to find K? I've got H. How am I going to find K? Substitute it in. By the way, keep in mind, you can literally type this in as is. So I would highly recommend everyone grab the calculator, type this in, and make sure you get the right value out. Okay? Practice typing that into the calculator. So you'll see the problem.
What's my name? Not like.
Why would you do today?
I just said true.
You're combining vertex and factors. When it's x, it's always
You true.
when it's x, it's always x minus.
I not do it right.
X minus h. Okay, plus k.
Do you?
So both roots is x minus
Who in
because
the world what?
if I substitute a negative r2 in, that doesn't make a 0. But if I substitute a positive r2 in,
How you do that, bro?
it makes that a 0.
You got a
So like remember that you're trying to
Oh, you got
create
an entry,
Yeah.
and then a function.
the 0 to 0. If you substitute a positive, oh there it was, sorry. If you substitute a positive 4 in,
Dude, did you make a line?
No, that's
it's not 0, is it?
Oh, never mind. I
You
do it.
want to create a 0.
So what, negative?
So you need the opposite.
So like if you have like just like basically
Negative 5, 2.
all in minus R2.
Oh, no. If I'm trying to find it, I got you. If you're trying to find an average,
Negative 2.
an average you just add.
Parentheses.
But just think about it as an average.
5/2,
Yeah,
negative 5/2.
So if that was
Still got
the, so remember, when we're trying to find an average, we just add the two things together.
Plus
divide by
1.
nine.
You know you said it.
That's why I did plus and negative.
That way you that's why you.
No, I'm talking about
You did minus.
what?
You knew it was the opposite there. You just subtracted the 4. I got -4. I got
She's
you.
gonna laugh at you.
So yeah, guys, this is a good point. By the way, did we type it in and get a value?
No.
Still struggling with it?
Hold on.
By the way, guys, hey, type it in exactly like this. Just don't forget, what does that fraction bar actually mean? What does that fraction bar mean, guys? It means division. So I would literally type out negative, and so don't put the f of x, by the way. That's just showing the input. I would type in -2 times -5/2 plus 1 times -5/2 plus 4.
Oh.
-5 divided by 2 plus 1. -5 divided by 2 plus 4. Yeah, you need the parentheses there. Yeah. This is telling to add before you multiply.
That's what I got.
Let me see.
There's just-
I'm not doing it.
You're not doing it right, Steve.
Reset it.
I do that.
Get like a post.
Just get a new calculator.
No,
It's not a line. I got 9/2. I don't think
9 halves or 4.5.
Yeah. I don't think
And
that's.
so I'm going to slightly adjust this. Notice I don't need this level of detail, but this makes my answer more precise. Or my graph more precise, I should say. Now I have an equation that I can write actually.
Negative 5/2 times 4.
So if I'm doing vertex form,
I gotta say the whole
what's my
thing.
A for vertex form?
No, just type 2. -2 times -5
Hey guys,
plus 1.
what's my A for vertex form?
Negative
Oh, -2.
2.5.
A is -2, yep, What's my H?
5.
-5 divided by 2. So when I do, so what's it gonna be? X and then what?
So 2.5.
So x minus a negative 5/2, right? But if I subtract a negative, what's that gonna become?
Positive 5.
Positive, right? So it's just gonna be the opposite. So don't forget, you always end up with the opposite inside of the parentheses. And then, what's next?
Squared.
Squared, good, I'm glad you remember that. Finally,
Plus 4.5.
plus 4.5 or 9/2, either one.
Yeah.
So, you gotta find h, you gotta find k. If you ever wanna go to vertex form, what do you have to find? H and k, right?
Oh, can we please have all juniors?
No.
S3Z come to the theater, please?
Okay. So, hold on one second. I know y'all need to go, but there'll be a line anyway. So if I get y'all to pay attention to this one detail, really quickly, there is always, let me say this again, there is always a way to get standard form. Okay. When I look at x plus 1 times x plus 4, what did you do in your previous math classes with an expression like that?
Multiple or distribute.
You can distribute, can't you? You can always get a standard form. You can always distribute. Even in B over there, can't I rewrite that as x minus 6 times x minus 6? And then distribute. So keep in mind, you can always get a standard form, you can distribute. I'm going to leave this work because I'm going to show a way to distribute that I really like. So you can go ahead and go, but just keep in mind, you can always distribute. So the way that I like to distribute is something called an area model. I believe Miss Williams used this, but if you did not have Miss Williams, yeah, it's that box, right, the area model. And in this area model, I just put my factors. I can only do 2 factors at a time. So what's a factor that I could put up here?
X
X plus 1.
And then
What's the factor that I put here?
X plus 4.
And then what am I doing with them? I am
Cross or multiply.
multiplying them. This area model helps me just organize it. What is x times x?
X squared.
X times 1,
1
or just x. 4 times x.
4.
And so notice how where they meet is where it fits, right? And then 4 times 1 gives me. This area model is a phenomenal strategy to help me organize. Could you just distribute like normal? 100%. By the way, some of y'all might have heard of the word FOIL. FOIL does not always work, so I don't use that term. Distribution always works. Using the area model always works. And all I'm doing is adding these terms together. Are there any like terms?
Yes. 1x and 4.
1x and
4x.
4x. What does that add up to?
5x.
So I've got x squared plus 5x plus 4. And then don't forget, we got a negative 2 out in front still. So now what can I do? Multiply or distribute, right? When it's only one term, I'm going to do that traditional distribution. It's when there's more than one term, I'm going to use this area model. There is my standard form. Does that make sense? Comfy with that idea? Questions? Okay. So I'm going to give you a chance to do some notes to yourself. After you finish some notes to yourself for A, I want you to work on B. One thing I'm going to tell you about B is I am not going to ask you to go to factored form with B or with vertex form because we haven't quite learned how to do it. However, we will learn next unit. But what does that mean you can do with B? You can go to standard form. Now I want you to think about it. I already gave a hint here with that. One detail to keep in mind, or not one detail, one thing I'm going to let you know is looking at time, think about where we are. We're going to finish today with writing equations of quadratics. We're going to do our demonstrated understanding tomorrow. However, that pushes our test back to Friday. I'm going to be out half of next week leading some sessions at the NCTM annual conference. It's just a Council for Teachers of Mathematics thing. And going to sessions, things like that. So I can't push things back too much. Test will be Friday, but that does mean Thursday we're going to start solving quadratic equations, but that's actually going to help us review some of this because it's going to apply a lot of the ideas we're looking at. So just be aware for the timing of things. I'm gonna push that test till Friday, but we will start the next unit. Man, way to be creepy. But we'll start the next unit on Thursday. We'll get some more practice on Thursday, test on Friday. Make sense? When's your demonstrating understanding? Tomorrow. All right, so take your notes that you need to for A. Start working on B when you are done with your notes, or your group is done with their notes. If you need to ask questions during this time, that'd be a great idea. Recording. Thank y'all. All right, so looking here at B, what was the first thing y'all did to start getting into that standard form?
The box.
The little box. What did you put inside that box? By the way, what do we call that box?
The distribute box.
It's an area model to help us distribute. I'll show you why we call it an area model in a second. This will actually hopefully make a lot of sense. But we use the area model to help us distribute. Actually, we got it right here. I'm not even going to do a terrible amount. Notice we started with just these edges, didn't we? And so what did we fill in? The what?
The box.
The area. Literally, guys, like if we're talking about the inside, aren't we talking about the area?
Yeah.
Think about it as like the base and the height. And we're filling in the area. That's why it's called an area model to help me, what is it helping me do? Distribute, right? If you want to call it the distribute box or whatever, you can. I just want you to be aware that we call it an area model because it helps us distribute. I also say that because I had someone who took advanced algebra 2 with me 2 years ago, and he had this Beasley last year, and he was just talking about like the boxes, and there was a lot of confusion because he knew what he was talking about, but she didn't. Like the language matters. So area model to help me distribute. That's all it is. So try to hold on to that language. So notice though, right, it was x minus 6 squared, or x minus 6 times x minus 6. That's how we get here. Any questions about this then? We all good?
Yep, everybody.
With that detail? All right. So notice we distributed. Notice right here, what are those? Like terms. And I want you to remember what's actually happening. This literally indicates we're doing what with our x's? Doing what?
What?
There is multiplication, but what does that multiplication mean? Repeated addition. I'm taking away x how many times? How many times? 6 times, right? Like literally it's taking away x 6 times. Then I'm taking away x how many more times? 6 times, okay? And so we get x squared minus 12x plus 36. And then we had a 2 out in front, and then a plus 5. And so I think a lot of us got close, but do notice there's parentheses around that, right? We're multiplying by 2, and what is 2x squared? Or 2 times x squared? 2 times x squared.
2x squared.
2x squared. There we go. What's 2 times negative 12x?
Negative 24.
Negative 24x. 2 times 36?
72.
72. And so this group was very close. What did they forget?
That 5 at the end.
Don't we need that plus 5 at the end here?
Yeah.
So what is the final answer? f5 of x is equal to?
2x squared minus 24x plus 77.
There we go. So keep in mind, because I see some of us didn't quite get there with that area model, just keep in mind, if I have x minus 6 squared, that literally just means x minus 6 times x minus 6. I need to distribute, so personally I'm going to use the area model. By the way, do you have to use the area model?
No.
No, but it will be very helpful. I was telling this group over here, because we're going to start doing multiplying 3 and 4 factors, and so that area model is going to help us stay organized. That's why I use the area model. All right, what questions do you have about that? Okay, take whatever notes you need to. I'm going to pass out the next little bit that we're going to do. You can go ahead and leave it recording because we're going to get started in just a second.
Alright.
So you can get to a factored form.
We'll be back.
But if you want, I'm going to go ahead and tell you that this is giving you a match.
Go take your notes. Go take your notes.
So actually, I should have said that. Hey guys, sorry, I should bring this up. Please notice, if we think about our graph, so eyes and ears here, so if we think about our graph, where did I put my chalk? I have it somewhere. Oh. And Xander, can you hand me that blue piece over there? I'm quite partial to blue. Plus, I don't know if y'all have used this chalk, but man, it writes so well. I know it sounds good. Plus, there's like this little plastic sleeve that so it doesn't get all over your hands as much. All right. What do you know about this function right here? It's in vertex form, but what do you know about the graph? It's what? Concave up. What else do we know? Concave up. A y-intercept of 5? I was saying, what form is this? This is vertex form, so my vertex is 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 5, and it's concave what? So you tell me, at least from what we know right now, can we write that in factored form? What do you need to be able to create factored form? You need 2 x-intercepts, 2 roots, right? Do we see any roots here? Well, there's imaginary ones that we'll learn about next unit. So we don't know it yet, is my point, okay? So just thinking about the equation, thinking about what form it's in, you can see right away, I don't have x-intercepts, I don't know the roots, I'm not going to do factored form yet. Okay? Does that make sense? What's your question with that, Miles? Huh? What do you? Well, that's to get to standard form. What we're asking about is factored form. What do you have to have for factored form? You've got to have the roots. And you have to have x-intercepts for those roots. Do you see any x-intercepts on that graph? Not all. What form is that? Okay, by the way, let's remind ourselves, x-intercepts are here, aren't they? Does that graph intersect the x-axis? So does it have x-intercepts? So am I going to do factored form? Not yet. You have to know how to find the roots. Okay? So we're not going to go to factored form with that one. Alright. So take what notes you need to. I'm going to pass out the next little sheet for the activity. But standard form. Can you always get standard form? Yes.
Can we have
Cannot always
first and
get
last
factored form,
name
yes.
starting with A, ending with C?
Okay,
before
so go ahead
changing for
and
pictures?
do your notes to your future forgetful self to help you with that information. We're going to get started on this in a second. Yes, ma'am.
Okay, so you see under the box, like,
Yeah.
3 equations down, what is that besides x?
The F5 of X?
Is that, yeah, what's that besides equal? Is that 2?
Yeah.
Oh,
2x squared minus 24x plus 77?
oh, okay.
Yeah. Because remember, it was x squared and we distributed that too, didn't we? David, you got all the notes for your future forgetful self that you need? So, create notes to your future forgetful self. Jeremy has this yard.
It's 19. I took so long. I just went there and know what I'm supposed to be doing this right now.
So I'm going to come back to some pages from the book. Don't put the pages from the book away yet. This is what I just passed out. And so what we are getting into at this point is learning how to write the equation of a quadratic function. Okay? And so what I want you to do as a small group is I want you to identify what equation you think we should use to write each of those, write the equation for these quadratics, right? So as a small group, you'll just put number 1 and you'll put which form it is. So when we look at number 1, do you think we're going to use standard form, factored form, or vertex form, or maybe even none? So maybe we're not going to write that equation because it would be too hard. Number 2, do you think we're going to use standard, factored, or vertex form to write that equation, or are we just not going to do it because it's too hard? And so I want y'all to just take 4 or 5 minutes, Again, these are just predictions. You don't have to get the answers right. We'll talk about it in a second. So let's get up to our vertical surfaces and let's identify which form of a quadratic you think we might use to write that equation. All right. So a couple of these a little tricky. Early on, I made it nice and easy for you. Number one, which form are we going to use? Vertex. Now, I did see a group that said or factor. What do y'all think? Could we use factor here? Why are they thinking factored? Any ideas? Oh, the vertex is in between the x-intercepts, isn't it? Yeah?
Yeah.
How does that help us with number one?
Get your what?
Anyone know what this point right here is? That's a what?
That's the
It's an x-intercept, right? The y value is 0? And I'll be honest, I had never until just now, when they actually put that, thought about the fact that you could use factors. Now, I will say this. So 1, 0, 1, 2, 3, 2, 4, 6, 8. So I'm going to go by 2s to make my life easy. So, 3, 7. So where would my other x-intercept be? Not 4, 0. How far is this from the x-axis, or the axis of symmetry? So it went from 1 to 3, so that's how far apart? 2, so it's got to be 2 away, so 5? So could I use factored form? 100%. Now, I will point this out. If you were thinking factored form because we have a root, that would not work, because how many roots do you have to do factored form? You have to have 2 roots, correct? So keep that in mind. You have to have 2 roots to do factored form. And so I would personally go with vertex. I already have that. You could do factored form. Number 2, what do we have? We're going to go with factored form because we have what? Technically, this should say x-intercepts. I just realized that. The root, what would the roots be in number 2?
Negative 5.
Negative 5 and 13, right? The roots would only be the negative 5 and 13. Those are x-intercepts. Number 3, do we have a vertex? Do we have a root?
No.
So you can use standard form. It involves creating what's called a system of equations. Maybe we'll do that if we have time at the end of class or at the end of the semester. But I'll go ahead and tell you this: I'm never going to ask you to start in standard form. Starting in standard form is a pain in the butt, so we're not doing it. The only 2 methods I'm going to ask you to create are vertex form and factored form. I'm never going to ask you to do standard. So this is correct. However, I'm not going to ask you to do it. Sound good? Number 4, I saw none. I saw some people thinking factored form. I saw some people thinking standard form. But I want you to look again at number 4. Did y'all figure out my hints earlier? No?
You said it's what's another word for the maximum?
Yeah, what's another word for that maximum point?
vertex.
Oh! That maximum's a what?
Vertex.
So what form are we going to go with?
Vertex.
I'm going to go with vertex form.
I knew it.
Notice and keep in mind, guys, if you have a maximum or you have a minimum, that's also the what of that parabola? The vertex. So I'm going to go vertex form.
Can we have freshmen last names D through F
No.
report to the theater
Not from
picture?
my classroom. All right. So now we actually need to learn how to write these equations, don't we? Lord, it's actually not scary. There's one small trick that we have to know with this. So I'm going to work on number 1 with you. Notice this is actually very similar to the number 1 from above. And from here, you're going to get a lot of practice with this. What form should we go with in number 1? I'm gonna go with vertex form, right? I've got a vertex. Now, one thing I will say is, again, you have one x-intercept, you could find the other. Factored form sometimes is easier than vertex form, but I'm gonna go with vertex form. Remember, write out that form right away. Boom. Anyone know anything for that equation? We got the h and the k, sweet! Life's easy. What is h? So what would I put inside the parentheses? So x plus 2 squared, then?
Minus 9.
I would say, you can, by the way guys, if you want to, literally substitute it in the way it is, but when I subtract a negative, what does that become? See, that helps me not make that mistake. When I do plus a negative 9, when you add a negative, that's the same as
Say it again.
adding a negative is the same as subtracting. So I can just rewrite this as minus 9. Just substitute it as is and then simplify it, or rewrite it if you need to. But what's the problem?
You don't have the A?
I don't have an A, do I?
No.
Any ideas? So one of the intercepts is 1, 0, right?
Don't you plug 1 in?
What could I substitute 1 in for?
The X?
Oh, now we're going to substitute 1 in for x. What can I do with that 0?
Y.
Isn't that the y value or my output? So what could this output here become?
0.
That's the output. I don't know a yet. What is y, or what is x?
1.
How many unknowns do I now have? I only have one unknown, don't I? What can I do if I have an equation with one unknown? There's 2 s's I'm going to talk about here. Simplify and then substitution. I have an equation that I need to know what a is. I got to solve that equation. Simplify first though. Always simplify. It makes your life simpler. Simplify first, then solve. So what would I do to simplify in this equation? Parentheses, what is that? What does that give me? So 1 plus 2 is 3. And you can jump to that next step if you're comfortable with it. What's next in simplifying? The exponent, right? 3 squared is 9. All right, what's next?
9, 8.
So I will point out, this is literally a times 9, isn't it? Or the same thing as 9a.
Yeah.
So thinking about that, can I continue to simplify at this point?
No.
What do I need to do now that I've simplified all the way?
Put your stuff back together.
I got what? What did you say?
Put it back together.
What do you mean by put it back together? I'm trying to undo these things. I want to know what a is. What can I do? How am I going to solve though? Say it one more time.
Move 9 to 0.
Ooh, let's work on that language a little bit. I'm not going to move anything.
Distribute 9 to 0.
No, distributing is that idea of multiplying.
Add 9 to both sides.
Okay, so remember, and what it really is I'm actually adding 9 to the right-hand side first. Hold on. This language is important because it's going to help you understand how to solve trig equations, square root equations, the whole 9. So trust me, okay? What's negative 9 plus 9?
0.
So remember, I'm trying to create a 0. That's what I'm really trying to do. I'm not moving anything. I'm trying to create a 0 there. And then whatever I do to one side of the equation, that's the idea of a property of equality. And so yes, I do add 9 to both sides. I'm not moving anything though. I'm creating a 0 and using that property of equality. And so I will point this out, you don't even actually have to use an inverse right now. You can see, what does a have to be?
1.
It has to be 1. Now you can also take the time to divide by 9. Remember, I like to use that reciprocal, that 1/9. 9 divided by 9 is what? 1. So a is 1. This one worked out really nicely. You think it's always going to work out that nicely?
No.
No, I wanted to give you a nice easy one to start. So we will start tomorrow with doing some more of these. If I were you, I would do every check your understanding question, graphing, things like that with check your understanding. We'll do this tomorrow for probably 30 minutes before we do a demonstrate your understanding. The demonstrate your understanding will have you creating, oh, sorry, we still have 3 minutes. Hold on 1 second. Your demonstrate your understanding will have you sketching a graph of a quadratic based on each of the 3 forms. So I will go ahead and tell you, I'm going to give you a vertex form, I'm going to give you a factored form, I'm going to give you a standard form, and you need to sketch it based on everything you know. And so I will remind you, if you have standard form, what features do you have to make sure are on that graph? If you have standard form, what features have to be on that graph that are correct? If you have a standard form, what do you have to have? Y-intercept and concavity. To have clear evidence of understanding, you have to be able to show me the y-intercept and the concavity and explain them. If you want to get to that exceeds portion on the proficiency scale, what else could you find about that quadratic? You could find the vertex, right? And the axis of symmetry. So that's that exceeds portion on proficiency scales. If I give you factored form, what features do you have to be able to show me? X-intercepts and concavity. What else could you find from that standard or that factored form? Vertex and y-intercepts. Remember, every y-intercept that's ever existed, the x is 0. So you have practice on that with the check your understanding. The other things that will be on the demonstrate your understanding is writing quadratic equations. That's what we'll start tomorrow with. So we'll get practice on that. The final thing is going from a factored form to a standard form. That will be on there. And so if you're like, Mr. Kinney, we haven't done enough of that. One, always remember that you can take any function on that on any sheet and practice converting it to standard form. And if you did it correctly and you graph both equations, what should we see on the graph? They're the same. So keep in mind, because I didn't put any practice, I will upload a video. I'll work on that during second block today with some more examples so you can see that. But keep in mind that if you're correct, they should map to each other. They should be the same graph. And so you can take any of them. I will pull some of the check your understanding questions to show examples of that. Have a fantastic rest of your day. And don't forget, you're always capable.